So today you're going to work on a review of radicals, rational exponents, and polynomials. I'm going to do my work in pen. You need to do your work in pencil. This is due tomorrow. You don't have extended time. I will physically collect it. All of your work needs to be on here. So, simplifying radicals, you have to pay attention to whether it's a square root, a cube root, a fourth root, right? Whether it's positive under there or negative. Can you take even roots of negative numbers? No. If you do, what do you have to pull out? Not a negative. Well, for instance, what's the answer to this one here? 4i, right? Because remember that the square root of negative 1 is equal to I. So the answer to this one is 4i. Because if you take the negative out, it comes out as I. That's the square root of negative 1. Because this is technically the square root of 16 times the square root of negative 1. If the square root of negative 1 is I, and the square root of 16 is 4, that's how we got that 4i. Think about that one. It's fourth root of negative. Can you take the fourth root of a negative? No. This one should be easy. How about, let's look at the fraction one. We've got two of them here, so I'll do the easier one. When you take the square root of fraction, you have to take the square root of the numerator and the square root of the denominator. So what's the square root of 64? 8, square root of 25, 5. Done. So that's that. Let's talk about these two. Why are these different than the ones up here? You have variables in there. How do you take the square root or the square any root of a variable? Remember? You just do it? Is that what you just said? That's too early. All right, so if this is a square root, you are going to divide that variable by 2. So before we actually talk about how that comes out, let's look at the 18. Doesn't 18 break down into 2 times 9? And isn't 9 a 3 and a 3? So it completely breaks down to 2 times 3 times 3. Because it's a square root, I want pairs of numbers. So don't I have one pair of 3's? So you're going to get a 3 that comes out in front. And then underneath the square root sign, the 2 doesn't have a pair, so doesn't it get left underneath? Okay. Then, when you take that root and divide it into your exponents for your variables, how many times does 2 evenly go into 5? 2 times. So we get x to the second, because 2 went in there 2 whole times. And then, what's the remainder? Just, yeah, we've got 1x remaining. So 1x remains. And the reason for that is x to the 5th can be looked at as x squared times x squared times x, right? Isn't this a pair of x squared? That's when x squared came out in front. Now, when you had even roots, technically you should use absolute value signs with your variables out in front if the variable we pull out in front has an odd exponent. In other words, I want a positive answer when I take this square root because it's implied that this square root should be a positive answer. And if x turns out to be negative, this would end up, if this were an odd exponent, this would end up being a negative answer. Fortunately for us, it's squared. But if it were to x to the 3rd, I'd put absolute value signs only around the x to the 3rd. That is not the same with odd roots. So if I pulled out because that's an odd root, if I pulled out an exponent that was an odd power, I don't have to worry about absolute values with odd roots because I can take an odd root of a negative number. Question? What are the what? All the other i's. So what are the, she asked, what are all the other i's? So if I is the square root of negative 1, then I squared would be square root of negative 1 times square root of negative 1. What is that? What's a square root times a square root? Same thing. So I squared is really equal to negative 1. So then I cubed is really this times this, isn't it? We never write the square root of -1 as part of our answer. You always have an I in there. So look at it this way. If I squared is -1, then -1 times I is a negative I. So I cubed is negative I. Because all I did was take I squared times I, which is I cubed. And then I to the 4th would be I squared times I squared, isn't it? So what's -1 times -1? 1. And then the pattern starts all over again. So I is 1 pattern of 4. Okay? Any questions on radicals for that section? All right, then rationalizing the denominator. You've only got 3 of them here, so I'm only going to do 1 of them with you. But technically, these two, you cannot have an answer that has a radical in the denominator. So these happen to be square roots. If they were cube roots, you'd rationalize using the cube root. But can't this one be broken up as the square root of 2 over the square root of 3? You can break a fraction up into 2 separate division problem. How do I rationalize? Yeah, whatever that radical is on the bottom, multiply the top and the bottom by that radical. I'm really multiplying by a form of 1, so I haven't changed the value of the problem. I'm just changing the way folks are moving it up basically. When I multiply 2 radicals together, I multiply what's under a radical to what's under a radical and what's outside to what's outside. And so because they're both underneath the radical, my answer, 2 times 3 is 6. That cannot be simplified. There's no pairs in there to pull out. Over, what's a radical times itself? The number under the radical. I cannot cancel the 3 into the 6 because what's outside of the radical cannot communicate in any way with what's inside of the radical. They can't associate with each other at all. So this is the answer. It is not square root of 2. So you'll do that on those two. Then converting radicals to their exponents and vice versa. So going in and out of exponential form and radical form. So I'll do the first 2 with you. This one, by the way, that right there is a negative. So it's -3/2. What does a negative exponent mean that you really do? It does not mean that z has a value that's negative. What does a negative exponent mean you do? Flip it, which means we're doing what? The reciprocal. So that negative means take the reciprocal. So when you take the reciprocal, you end up with 1 over z, bless you, to the positive 3/2. When you take the reciprocal, that negative goes away. So then from there, I'll let you put that into radical form. So we're going to talk about these 2 now. So this one is in radical form. That means we're going to put it in exponential form. When you're looking at something, here's a base of A, and you've got an exponent of B over C. C is the root, and B is the, I hesitate to say power because technically a power is a base in an exponent, but so I'm just going to put exponent. That the item underneath the radical is raised to. So here, my base is going to be the x plus y. That's my base. So whatever thing is being raised to an exponent, that's still your base in exponential form. What is the root that I'm taking? A square root. So that means the denominator is a 2. And they raise this x plus y to what power? 3. So it's to the 3/2. So this is the power it's raised to, the 2 is the root that we're taking. So if I were taking the 4th root of x plus y to the 3rd power, I would have had a 4 down here. This one's an exponential form. We're going to take it apart and put it into radical form. Are both of the denominators the same? So I can put them both underneath the same radical. If they were different denominators, you'd have them in 2 separate radicals, because one would be, cubed, let's say, and this one, if it were a 4, would reach the 4th root. So watch for that. So because they're the same, I can go ahead and put a cube root here because of that denominator. Now, your x is raised to what power? The second. And your y is raised to what power? The first. I'm just going to leave it. So this is your answer for this one. And this is your answer for that one. So, yes? Let's just say, for chuckle's sake, that you had x to the 2/3, y to the 1/4. Because those denominators are not the same, you can't have them underneath the same radical. So I would have written, and 9 times out of 10 you're not going to see it that way because it's just not normal. So you would take this one and it would go underneath the cube root because of the 3. The x would still be squared. And then it would be times, use multiplication and parentheses also. This would be underneath the 4th root and it would just be 1. Any other questions in that section? Okay. And then flip it to the back. So let's talk about our exponent rules. When you have a power to a power, so power to power, this is a power to power, x to the a to the b. What do you do with the exponents? You multiply them. If you have like bases, what do you do with the powers? And then you're multiplying those like bases. You add, whoops, that's an x. You add the exponents. If you have like bases and you are dividing, what do you do with the exponents? You do subtract, but you subtract typically where there are more, so you don't get a negative exponent. We're going to assume that a is the bigger. It technically could be b minus a as well, but you want the one that gives you the positive exponent. And then, okay, so let's look at 2 examples before I go over here. If I were to look at let me ask you this. What's the exponent? 3. What is the base raised to that exponent? Is it x, is it 7x, or is it negative 7x? It's just the x. The only thing that's raised to the 3rd power is the x. That negative and that 7 are not raised to the power because they're not in parentheses. Now, if I were to write it this way, now the negative and the 7 and the x are all raised to that big. So parentheses make a difference. So be aware of that. So here, I think I'm going to do just 17. I think you can do those ones on your own. If not, you can ask questions tomorrow. So here, we're going to apply our rules. I want to apply this rule first. You think of, please excuse my dear Aunt Sally, before I can multiply, don't I have to raise things to an exponent? Please is parentheses, excuse is exponent. So I have to clear the exponent first before I can, my dear, multiply and divide. So we're going to raise this to the 1/3. What does the 1/3 imply is happening? We're really taking the cube root here, aren't we? But we're going to go ahead and multiply. We've got a power to a power, so we're going to multiply exponents. So we've got x to the 2 times 1/3. Nothing cancels. 2 times 1/3 is 2/3. Good gracious. The building is falling down. 9 times 1/3. Doesn't the 3 cancel into the 9? How many times? So we get y to the 3rd. And all of that's in parentheses times xy squared. So now we have a change in rules. So we're not doing power to power anymore. We're multiplying like bases. So what do we do with exponents? You add, and this exponent you can't see here, so it's understood it's a 1. But I really don't want to look at it as 1 because I have a 2/3 here. How else can I write that exponent? 3 over 3. Right? So now when I add these exponents, what is x2? The 5/3. And y has 2d. Add. Yeah, it's easy to say 6. Add, you get 5. And so there's your final answer. And so here you're going to be dividing like bases, so you will end up subtracting. Make sure you subtract where you get a positive exponent. And that is a negative right there. That's a negative 1/2. So if you want to take care of your negative exponents before you start, like on this one, you could just swing only the x to the negative 1/2 because the 2 is not raised to that negative 1/2 power. You could swing it down below, and what happens? It becomes x to the positive 1/2, right? And then, well, you could do that, or you are multiplying here. If you add exponents, which is bigger, 2/3 or negative 1/2? Or which is bigger, 2/3 or 1/2? 2/3. So if you add those, won't you get a positive exponent? So you could keep it right where it is. But what's the problem with this particular one? How do you add 2/3 and a negative 1/2? You have to get common denominators. And what's the common denominator? 6. So make sure that you change those. Same thing's going to occur down here with the y's. True? No, because the 2 is not raised that 1/2. And if you do that, now your x is here and your x is down the bottom here and your x is up here, then you would end up subtracting those exponents. So it's probably easier just to keep it upstairs, if I were you. Wouldn't you just multiply the 2 and the 3 together? Yeah. You get 6. So they are separate from each other, they're not attached. All right, so combining radicals. How is it that I can add and subtract radicals? What do I have to have? Yeah, your radicals have to be the same thing underneath. So right now they're not. So right now I cannot subtract these, but I certainly can simplify 80 and 125. So 80 factors into 8 times 10, and 8 is 3 2s, and 10 is a 2 and a 5. So I get 2 pairs of 2's. So out in front here, I have my original 2. Then I'm going to pull out 2 2's. So I'm pulling out a 2 from each of those pairs. And then I have left underneath my radical that 5 minus the 125 is 25 times 5, and the 25 is 5 and 5. So for this one, I have a pair of 5's. So only 1 5 comes out in front. There was nothing there originally. So get rid of that 5, it doesn't pair up with anything that's left underneath. So really what I'm subtracting is 2 times 2 times 2, which is 8 rad 5, minus 5 rad 5. Now that they're the same radical, this is no different than saying 8x minus 5x. If I have 8 of these minus 5 of those, how many of those do I have? So I get 3 rad 5. So that's what you're going to do on the other two. Make sure you simplify. Oftentimes it's easier to completely prime factor than just circle your pairs. All right, last section. Adding, subtracting, multiplying polynomials. Be really, really careful. I'm not going to do most of these with you. These ones you're just adding like terms, right? We're not multiplying. Don't multiply here. Just find your like terms. So I'm looking for terms that have the same variables, raise the same exponents. So if I have 2 of these and I add one of those to it, how many x cubes do I have? You get 3 x cubed. And then you're going to continue on. You're going to combine your squares, your x's, and your constants. What's the difference between 23 and 24? You have subtraction here. Before, we don't ever subtract in algebra. We always add the opposite. So I would change this subtraction to addition, but you have to change all the signs inside. So this subtraction becomes addition, and then we get a negative here, a negative here, a positive here, and a negative here. So now you're doing the same thing that you did before. So I'm combining, I don't have any other x cubed, so you have a negative 2x cubed here. So that's all by itself. But we do have x squared, so I have two terms that are x squared. So now I have a 4x squared and a negative x squared combining to give me a what? 4 minus 1 is 3, so I have a positive 3x squared, and I'll let you finish that one. Multiplying, use your rule for multiplication. When you multiply like bases, what do you do with the exponents? You add. So here, you're going to multiply coefficient to coefficient and like base to like base. So I've got 2 times 1 is 2. X times x squared, 1 plus 2 is 3. Wrong class? No, x cubed. And then do it again. 2 times a negative 1 is a negative 2. X times x, we've got 1 and 1. So that adds to give us x squared. 2 times 3 is 6. There is no variable, so you just tack on the 1x. You have no more like, you have no like terms here to combine. That's it. That's the square. So I'll let you do that one now. All right, so this is the class where some of you are going to have to share a computer. So if you will go back there, grab a computer, and turn it on, we are going to sign up for Math Excel.